Fractal curves have infinite detail, but they are based on simple rules for growth. For me, fractal curves provide a kind of geometrical nourishment for the mind. Watch how this curve grows. It folds up into itself and becomes more curly, while the endpoints stay fixed in place. Why does it resolve into this strange dragon-like shape? Fractal curves are not only useful for illustrating the concept of fractional dimension or for describing the length of a coastline, they also offer an endless supply of geometrical puzzles. For those of us who are fascinated with biological growth and form, studying fractal curves is a bridge to learn some interesting mathematical concepts. Watch this curve grow. No matter how long it grows or how tightly curled it becomes, it never touches itself or crosses over itself. It's a self-avoiding fractal curve. Notice that this curve keeps filling up a region of space until it is completely filled in with the curve. This means it is a space-filling curve. So what's the trick in designing these amazing shapes? How does it work? Well, it has something to do with flipping babies. Let me explain. The famous Koch curve will serve as my first example. The generator for this curve has 4 segments with a triangular bump in the middle. Now I'm going to make 4 small copies of this generator. It just gave birth to 4 little babies. Each baby is placed onto the mother, one for each segment. Now each segment has a bump. This process is repeated over and over again. That's what makes it a fractal. As you zoom in closer and closer, you keep seeing the same visual detail. Now watch what happens if I flip one of the babies, like this one at the end. Notice that the bump is now aimed downward. So the next generation of babies are affected by this bump, as you can see here. It's not exactly pretty, but it illustrates how one flipped segment can make a difference in the overall shape. Now, as far as I can tell, in order for a space-filling curve to be self-avoiding, it must have at least one flipped baby. All the well-known space-filling curves have this property, as well as all the others I've identified. Here's a 5-segment generator. I'll replace each segment with a small copy of the generator. If I repeat this process again, notice that the curve starts to overlap with itself. It's an interesting shape, but let's see if we can get it to be a self-avoiding curve. Now watch as I flip the babies on these 2 segments, and then let it grow. These bumps grow in the opposite direction, staying out of the way of the other bumps. There's a lot more I can say about this, a lot more, but it'll have to wait until my next video. Until then, check out fractalcurves.com or visit me on Blue Sky at this address. I'm preparing to make a new book about fractal curves. It will include lots of color images and some newly discovered fractal curves to fill your brain.